Okay, good afternoon, everyone. Let's make a start, shall we? Welcome to the briefing. Thank you all so much for signing up. The way it's going to work is I'm going to introduce 3D printing to you and its application in the humanities. Then we're going to hear from the librarians in the makerspace, and we're going to actually go downstairs. Is that right? Yes. Okay. We'll have a trip to the makerspace, and then we'll end with more details about the competition, and we'll give you an opportunity to sign up right now today. Let's make a start, shall we? 3D printing in the humanities. You've probably heard of 3D printing. You're all students in the Faculty of Arts, so you know about the humanities. But how can we put these two things together? I'll start just by reminding you a little bit about 3D printing. You've probably read about it. You might have even done some of it yourself. But in many ways, what we're doing with 3D printing is the same as 2D printing, right? We're creating reproductions of images and objects, but in 3D rather than 2D. 3D printing has another name, which I think is in some ways more helpful. It's called additive manufacturing. Additive manufacturing, which means creating things by adding layers. Okay, if you look at the image on the screen, you'll see the head of a rather famous statue being created layer by layer. This, of course, requires a three-stage process for actually, sort of conceptualizing it. Design, slicing, and printing. With the slicing, the creation of these layers and a sort of blueprint for their shape being what differentiates 2D printing from 3D printing. What's 3D printing good for? Loads of things, right? They use it for making car parts for airplanes, prosthetics, so fake limbs, in architecture, in fashion, in all sorts of different domains of life. And the great thing about 3D printing, okay, it can be customized. You can make exactly what you want, as opposed to having to rely on mass-produced items. You can make it really quickly. You can make it much more cheaply. You can do really. It gives you a level of flexibility and a level of customization that you wouldn't have otherwise. It's used by us in the humanities as well, especially in museum studies, but also in art history, urban history, and other domains. It's great also for developing certain skills which we as humanists might want to cultivate. It's great for making us think about design, about physical space, and of course, in the museum space, in the museum context, it allows us to replace and substitute objects that otherwise, we might not be able to handle. Okay, there are lots of different possible advantages. I'll just give you some applications. Okay, mixing the kind of world of medical prosthetics and museum studies, it's actually quite common now to restore historical artifacts using 3D printing. So say, your statue is missing a thumb or a nose or some other part of its anatomy. you can 3D by a combination of 3D scanning and CAD, you can create essentially a prosthetic, and you can, as the image suggests, you can restore an otherwise broken piece of sculpture. It also allows us to democratize collections, and this is something that the British Museum is very involved in. They've put a large number of models of their collections online via Sketchfab, and you at home can print your own version of objects in the British Museum. Okay, it's all essentially copyright free. You can bring the British Museum to your home, to your school, to your community, in a way that just wasn't possible before. Those of us who work with texts have also started applying 3D printing. There have been some wonderful objects created by a scholar of Korean poetry called Wayne DeFremery, who recently gave a talk to us in the Digital Humanities Initiative. He has been 3D printing I guess, visualizations of the Unicode of Korean poetry to give us another way to think about and consume poetic works. A lot of people in the fine arts space have also been experimenting with 3D printing, and not only using, say, plastic or rubber-like materials, but other materials too. This is an example of an artist based at Harvard who has been using 3D printing clay. So he's been creating clay objects, which we normally be producing by other means, but with 3D printing. Okay, so these are our applications. So if you're interested in 3D printing, which you obviously are if you're here, how can you go about doing it? Well, it's really easy. Here at CUHK, we have the facilities and all the expertise to help you. You'll see that in the next presentation. If you want to go about actually doing it, well, there are various ways. You can get pre-existing 3D models. The file format is STL. STL, it's just like a file extension, so like PDF or something. As long as you have a file in that format, you can that can be read by a 3D printer, and you can produce your object. There are lots of free as well as paid databases for these kind of models. Sketchfab is probably the most well-known example, and that's the one through which the British Museum objects are available. Alternatively, you can, as it were, draw your 3D model. There are various CAD softwares out there that you can use. Again, as long as it's in the STL format, you can print it out here. The final option is essentially like Xeroxing, like photocopying. Download an app to your phone, 3D print an object, and then you can reproduce it with your 3D printer. Okay? Of course, just like Xeroxing, just like photocopying, we have to think about copyright and fair use. For us in history, that's maybe less relevant than for other disciplines in the Faculty of Arts, but it's something we obviously have to bear in mind. Once we have our model or our design or our 3D scan, we can then think about not only the size we want to print it out, do we want it to be full scale or smaller or perhaps larger, and then about the colors and materials. You'll see in the makerspace there are 3D printers with a number of different materials, some more like plastic. There's a new one which uses something more like rubber. That'll depend on what you want to create. And then there are color options as well. So these are all elements of the design that you will want to think about. Another great thing about CUHK, 3D printing is free. The actual use of it is free, although you will have to pay for the filament. Although not if you're taking part in the competition. That will be covered by the competition. But if you want to do it outside the competition, there's a charge by gram. Okay, so that's my basic introduction. I hope it's whetted your appetite for the next presentation and the visit to the makerspace. I think at this point I'll pass the mic over and we'll hear.
So we go through my PowerPoint first, and then visit the makerspace later. Thank you. Okay, in this session, let us talk about how to prepare your 3D model for the competition. Actually, we have many ways to prepare the 3D model file. The first way is create by yourself, create the file from zero, and then or you can do some 3D scanning to have an initiate file and then do some touch up to do the finishing. Or you can explore some 3D model file from the internet. After you got your 3D model, how to do the 3D printing or any post-processing works. I will talk about this in this session. Okay, first of all, how to prepare your 3D model file. You can draw it by yourself. Here is some recommended software. We call it computer-aided design software, CAD software, for you to create your 3D model file. The first one is Thinkercad. Thinkercad is very easy to use software for beginner to design their 3D model, which is free of charge. It has application, so you can download the Thinkercad apps on your mobile device, and it provides a very easy to understand online tutorial for you to learn about it. For me, I believe that you can use around 1 day to get familiar with the whole platform, or even few hours. And for this software, it can export the file type to .stl or .obj. These two file type is commonly used in 3D printing. And for the 3D printer in Makerspace, also using these two file type. Okay, and then the pros and cons of using Thinkercad is it is easy to use for beginner, and it is cloud-based, so that even you can register your free account or use Gmail account to log into the platform and do your design immediately. And then it also provides some template for you to import to your design. And the cons is it is hard to create some compact shape. Here is an example for you. Even you can see this sphere. It's very simple shape, but when you look into it, the shape is, yes, you can pass it to other students. The shape is not very smooth. Then you can see this sphere is made by Blender, and the shape is much better than that one. So you can compare the difference. This is the disadvantages of Thinkercad that cannot do very complex shape, right? And the resolution is not very high. Okay, another software I would like to introduce is Blender. It's also free of charge. It's not cloud-based. You have to download and install in your computer. It is for 3D modeling. Actually, not only 3D modeling. You can use it to do 3D rendering or even 3D animation. And then it provides online tutorial, even not the official tutorial. You can find many video tutorial on YouTube to teach you how to use Blender, but it is not easy. Even if we want to learn how to draw donuts from zero, maybe you have to watch around 10 hours video to learn how to draw donuts. Even donuts is actually a simple shape and not very difficult, but it also takes a long time for you to learn how to use the platform. So it is a little bit difficult. And then you can find the installation from the internet by yourself, or you can make use with the high performance workstation at the Makerspace, because we will already install this software for you. And then the post of this Blender is available for Windows and Mac OS platform. It provides precise 3D object placement and then manipulation tools. For doing some shape like this, use Blender will be better. And then with the disadvantages of Blender is slow rendering time and crashes during complex project. It also not supports some 3D object which has many surface. For the surface, number of surface if more than 500,000, it will be very slow or cannot support. Okay, and another software I would like to introduce is SolidWorks. It's quite popular, and even some manufacturer also using this software, but it is not free of charge. We have to buy the license, and for the workstation in Makerspace, we already provide this software for our students and staff, and it is actually, which may be easier than Blender. The interface is more easy to get familiar, and the strength of SolidWorks is for doing some design like engineering tools, some mechanical system, machine, and it also provides some simulation when you build your 3D model. Maybe it is a model, and then it provides simulation for you how it moves in 3D object. And then the disadvantages of this software is the cost is quite high, and then the hardware required for your computer is high. So we install it in our high performance computer. And this software support Windows only, not for Mac. Another software is ZeroBrush. It is also, we also have to pay for the license, and actually it's quite expensive. We provide this software in our high performance workstation as well, and it is quite difficult to learn about it, but it is very powerful. And it does scripting very well and support some complex 3D object with many surface, even more than 1 million surface. It can also support it. Okay, it is the introduction of CAD software, and then now we talk about we don't create the 3D model by ourselves from zero. We try to do the scanning first. Actually, a few years ago, we used some expensive 3D scanner to do 3D scanning. However, even the scanner is very expensive, the performance may not be very well or excellent. And now the technology is very good. Even a mobile phone with an 3D scanning application, you can do the 3D scanning by yourself. Here's two application I would like to introduce to you. The first one is Metascan, the second one is Polycam. For Metascan, it is a mobile application. You can do the 3D scanning for iOS and web. Actually, the result is quite accurate with the 3D model, and it can support export the file format to .stl and .obj. If you remember that our 3D printer also using these two file type to do the 3D printing. So if you support exporting the file to .stl and .obj, that means you can do the scanning and then print it out by our 3D printer. Okay, another application is quite similar to metadata. Actually, these two applications, no learning path. You just download the app and then open it. You will know how to do that. Only take 2 seconds to get familiar with few buttons to operate this application. This one is quite similar with metadata, and it provides different mode, photo mode, LiDAR mode to do the scanning object. LiDAR is quite popular function provided by iPhone 12 Pro or upper level. For you to do some big scale object scanning, or even some space, such as this room or a big building, you can use the LiDAR function, but it's supported by iPhone 12 Pro or upper level only. And then some tips for doing 3D scanning. Make sure your camera lens are clean, and then the camera pixel affects the results a lot. So use a better camera, you will get a better results. And before you do the scanning, you have to plan your path, how to do the scanning. Go through all paths of your target to make sure it can capture all the photos to form the 3D object. And then don't move the object or camera too quick, and the performance of this 3D scanning application for shiny, dark, hairy, or clear objects not very well. So sometimes people some people, maybe salesmen, demo their 3D scanning to scan real person. They will put on a hat to cover the hairs in order to cover their disadvantage of the 3D scanner, because many 3D scanner cannot do very well for hairy or dark shiny object. And then for learning garden and makerspace, we provide some accessory to support your 3D scanning, such as we have Creative Media Studio with very good lighting, and then we have triple turntable and light spots for you to do the scanning. And here is some video for you to learn how to clean up your 3D model. After the scanning, the model won't be perfect, such as this one. This is Muppet from CC Collection. We do the 3D scanning by the application Metascan. And then you can see the outcome is quite good, but maybe here are some area I don't want it. I want to eliminate them. Then I can use the software Blender or ZeroBrush to delete the unwanted part. Okay, after 3D scanning and touch up, we can talk about how to find some 3D models from the internet. Here is some recommended platform for you to find 3D model file, Sketchfab, each, and then Thingiverse. The first one, Sketchfab.com, is a 3D modeling platform for people to publish, share, discover, buy, or sell 3D model. If you know how to create 3D model, you can also create yourself and then upload them to this platform to earn some money. Actually, most of their file need to pay, which is not very expensive. If when you select the file from the internet, no matter have to pay or free of charge, you have to be aware that is it downloadable and printable format. You have to check the format here. Here's the formats. That means after you pay for it, you can download the file type. If you remember that we support .obj and .stl file for doing 3D printing, and some file types such as .glb is only for online view only. So if you only download the GLB file, you cannot do the 3D printing. So you have to check, do your 3D printer supports that file? And then another platform is EG. This platform is actually a search engine. It redirects you. It provides so many 3D models, and most of them are printable. Around 5 million 3D models file from other websites. So you go to this website to use keywords to do the search, and then when you click the model, it will redirect you to the third-party platform for you to download, and then some of them, maybe you have to pay for it. Another Thingiverse platform actually also holding by the software Thingiverse. Even not all 3D model created by Thingiverse, maybe other software, but the people upload a file here, they most likely share it without any charges. You just download the file after you register an account and no need to pay for it. And some of them will share, some of the creator will share their printing setting in the details. Because after you download the 3D model file, you may have to do the 3D printing setting, such as the infill, the wall, or the layer heights, which setting can help you to print the perfect product. The creator will give you some tips. Okay, after the 3D printing, after find the 3D model, we talk about how to do 3D printing. For the learning garden and makerspace, we apply in 3 kinds of 3D printing technology. The first one is FDM, the most popular and easy to use 3D printer, and then the second one is SLA, and the third one is PolyJet. I will introduce them one by one. The first one, FDM, just like the technology mentioned by Stuart, this is layer by layer to build the 3D object from the 3D printer. It uses the material which is maybe a plastic, polyester plastic, to be the filament to go inside the nozzle, and then extrude the material, melt it, and extrude it to form a layer by layer to form the 3D object. And the material provided by us is PLA, PVA, and TPU. PLA is the most widely used material in 3D printing. It is very cheap, and then many color or even texture, because some filament may add some wooden or metal powder inside, so that even it is a PLA, it is a plastic, but it looks like wooden or metal. And then PVA. Thank you. PVA is this one. This one most likely use it as a support material. It can melt in water. If I soak it in warm water, it will be soft and then easy to check it out. Because if we don't use PVA, maybe we can use PLA to do the support and the printing object together. But actually, if we use PLA to do the support and the 3D object, it is very difficult for you to remove it. And when you remove it, maybe it hurt the original object. So PVA is very good for support material. And this one is also using the FDM 3D printer to do the printing. So you can pass it to others to see the effect. And then TPU is another object. It is also plastic, but it is elastic, and then melt processing support for you to do the extrusion process. And because it is elastic, maybe you can apply to different objects such as shoes or cast tie. This is the latest, the newest 3D printer for FDM technology in Makerspace. We have PLA, PVA, and TPU material for you to choose, and it supports STL and then OBJ file. And the build volume, please beware of the printing volume, because we have limitation of the size. If you want to print a big object, you may need to cut your file into different parts. After print it, you can stick them together if it is bigger than our print volume. And then the charges of this for using the 3D printer is free of charge, but we charge you the material cost. The cost is $1 per gram, and the basic charges is $20. Another technology is SLA. The material we use is resin. Actually, resin is liquid, and then it uses laser to put on the resin to form the solid object. So the result is very high accuracy. So you can see for the FDM object, after you print it out, you may see because it built layer by layer, you may see the layer, so it will not very beautiful and very fine. But for SLA technology, the result is very fine. People always use it to print some figure, maybe Marvels or some Japanese comic figures. And then here's the material is high resolution, accurate, and the surface is very smooth. But the disadvantages is very expensive. For FDM, we charge the cost is $1 per gram, but for SLA, you use the resin charge $6 per gram. It's 6 times of PLA. We also support the file type is STL and OBJ, and this is the printing volume, and the cost is $6 per gram. And this is the model we are using, Formlab 2, for SLA printing. Okay, And then this one, PolyJet, is our newest 3D printer using the PolyJet technology. That the print head has so many nozzles, around 2,000 nozzles to do the printing. And then it's different from SLA or FDM because they the color of FDM or SLA are limited by the material. The material is great, then the printout is great, right? But for PolyJet, it also use resin, a kind of resin, and the color is immediately mixed by the source color. So it supports Pantone color printing. This is also the printout from PolyJet. And this is human brain, also printouts by the 3D printer without any post-processing. I didn't print the color by myself. It print out already like this. And even the Oracle is also printed out by the PolyJets. So high accuracy, good quality, and then multiple color and material is the advantages of PolyJet. But the disadvantages is it always needs support, and the infill is always 100%. So somehow it uses lots of material for it. And this is the model we are using in Makerspace J55. We support the file type is also STL and OBJ file. But please be aware that the difference between PolyJet and SLA or FDM is we need the texture of your 3D model file. Because when you see the PolyJet output, we have color, right? But for FDM, we no need to be aware of no need to mind the color because the printout depends on the material or the filament, right? But now for PolyJet, we have to print the texture together with the object. So when you provide the file for these printouts, you have to associate with another file, .mtl file, for the texture. .mtl file is controlling the texture of your 3D object. Or we have another file type .vmf. It is combined the texture and the structure of the 3D object to do the printing together. And this is the print volume of this J55, and the printing cost is $2 per gram, even lower than SLA. Okay, some post-processing work. You can click the hyperlink here to read more about post-processing work. Actually, it depends on different printing technology. You can paint by yourself. You can do some coating or gild with you if your object's too big and then out of the printing size, then you print them in different parts and then stick them together. You can use some sandpaper to make the surface more smooth. Yes. So you can click the hyperlink for more details about that. That's it for my introduction about 3D printing. Do you have any questions? If no, then do you want to go through your competition or go to Makerspace?
Yeah, maybe we can talk about the competition
And then visit the Makerspace.
and then we can head down. Yeah.
Okay.
All right. Okay, just give me a second. Okay, great. So let's talk a little bit about the competition then. We're obviously here at the briefing on 3D printing and 3D modeling. Your next step is to form teams. to take part in the competition. Each team will be producing a 3D printed museum of 5 objects. 5 objects related to Hong Kong in the 1960s and 70s. So a very sort of fun, visually, sort of exquisite kind of topic, we hope. You, as teams, will put in a proposal, just a brief outline of the objects that you want to reproduce. And then once we've got the proposals, we will choose the teams to take part in the competition, 4 teams, and each team will be given $1,000 of printing credit. So you should be able to print really, whatever you want. Just a couple of things about those 5 objects. 2 of them should be produced using 3D scanning. Okay, so say you have your 5 objects. 2 can be, 3D scanned, objects that, I don't know, maybe even belong to your grandparents that you sort of find in Hong Kong. Okay, and then the others can either be designed by you using CAD or can be downloaded and then edited using CAD software. But we'd like you to have the experience of 3D scanning because it's really it's something that's so easy now and is really worth learning. The teams will also get some additional help from the staff here at the library and in the makerspace. We'll give you an extra workshop. You'll get all the help that you need to take part in the competition, leading up, of course, to the deadline on April 1st. We'll then get some expert judges to decide the winners of the competition, and then all the museum pieces will be displayed here in the university library, probably as you come in. So all your friends will be able to come and see your objects and learn all about Hong Kong in the 1960s and 70s. There'll also be prizes in the form of book vouchers for the various winners. The sizes of the teams can vary. We're very flexible. We hope that there'll be students from different years, from different departments. We hope it's an opportunity for you to work together with your friends and maybe make new friends by working on 3D printing together. Okay. We also have an option. We also have the QR code as well for you to sign up today. But of course, you can sign up afterwards as well. Does anyone have any questions? Okay. Well, when we head down to the makerspace, you can obviously talk to any of us and answer questions to us directly. So I guess at this point we'll head downstairs and we'll see the makerspace.